Okay, hello everyone. My name is Sitnik. Today I'm going to talk about building scalable cloud-native apps with .NET 8. Who has ever been to my previous talks here? Is there any? Oh, nice. The last talk at Warsaw User Group, it was 2017, like 2 years before pandemic. Like, let it sink for a moment. So, typically I speak about things that I understand in 100%. Today, the case is different because I was contributing to Aspire for like a few months, and then I have left the project, and there are some aspects that I don't have ultimate understanding. Yeah, so please expect that there will be some questions that I won't be able to answer myself, but I have registered on the meetup, so in case this happens, I will just post answers once I get them from David Fowler or Damien Edwards. And without further ado, let's go. So, cloud native. .NET is investing heavily in cloud native team, mainly because we want to stay relevant. We don't want .NET to be perceived as a framework for building desktop apps. And because of that, over the last few years, we have been heavily investing in things like yet another reverse proxy in Project I. ASP.NET had introduced the concept of Heltex, HTTP Client Factory. We have super fast gRPC implementation that is beating Go. We have also, in .NET 7, invested a lot in native AOT and in SDK container builds. In .NET 8, our main focus was on R9 and Aspire. And before I get to Aspire, I would like to talk about R9 because it has introduced a lot of cool things into .NET 8. So what is R9? R9 is an internal SDK used at Microsoft by high-scale services written in .NET. A good example is Teams backend. Some of these services are handling billions of requests per day. And of course, they are reusing the code. We had this internal SDK, and our architects sat together with the architects of R9, and they had a discussion about whether some of these things should become part of .NET or ASP.NET or should be open in general. So, the first thing that was added in .NET 8 is finally an abstraction for time provider. So you may, it's not a big deal if you take a look at the interface, at the abstract class itself, but what is the most important thing is that there are plenty of new overloads in base class library, for example, new task methods that accept an instance of this time provider. So now you can easily test, for example, cancellation of your methods without doing any ugly hacks. The other thing are frozen collections. Have any of you ever used immutable collections in .NET? So the problem with immutable collections is that they were designed to mainly solve one problem, namely collections that are immutable but can be easily extended by adding a new element. So they're immutable, but they expose an add method. And because of this contract, we were limited in terms of performance improvements we could make. So frozen collections are collections that are frozen. You specify the input, and you can never change them. They are also part of system collections immutable. I had the pleasure to tune some of them. And the main difference with all different collections is that when you are creating a frozen collection, it's trying to choose the best strategy for given input for providing you fastest read access. And how fast can it be? It's cloud native, but I had to sneak in some benchmarks. So, for example, if we iterate over 3 dictionaries, the immutable one dictionary, a frozen, and regular dictionary, you can see that the frozen getting keys, like getting elements by key in a loop is like 14 times faster compared to immutable dictionary and 50% faster than regular dictionary, which have been extremely heavily optimized over the years. And if you take a look at this benchmark where we are searching for names in hash set, in a frozen set, you will see that frozen set in this particular case for this hardware is 8 times faster. How is it possible? As I said, when we are creating it, we are choosing the best strategy. So for example, you are providing a set of strings, and we are checking whether the lengths are unique or whether we could group them into small groups by length. And then when you are trying to access something, we are not calculating the hash code. We are just checking the length and our first level of our map. And we are like, oh, nothing of this length belongs to this dictionary or this set. There are some other strategies. Some of them are checking if we can skip common prefix or suffix. For example, if you have paths in ASP.NET app, let's say that you have, /home/test and /home/abc. This strategy, there is a strategy that will decide that, oh, I don't need to check the hash code for first 6 elements because they are the same for all of the strings. So this is kind of magic. Because of that, they are more expensive to create, but they provide very fast read access. So if you have ever gotten to the point that your hot path is in dictionary or in hash set, and you were thinking that there is no way of optimizing it, now you can switch to frozen collections, assuming that your input is not changing, or at least not very frequently. Another nice addition to collections, all of the collections, the read-only collections and their interfaces were extended with an empty property. And another big feature is keyed dependency injection. So now you can register multiple things of the same type, but you need to specify different keys. So let's say you're having a web app that is having a primary and a backup Redis connection. You can register the first one under key primary and the second under backup. And when resolving, you also need to specify these keys. What is important, there is an API called keyedService.anyKey, which basically works like an else block. So when resolving, and you don't specify a key that was specified for any other registration, this item will be resolved. And of course, when you are injecting via constructors, we also have an attribute for you where you can specify the key. And a key is an object, so it can be anything. It can be string, it can be type of, it can be integer. Personally, I recommend to stick with something simple like string or type of, because it will be faster and easier to understand. Another thing that we took from R9 is a set of analyzers. Plenty of them are focused on performance. And my most beloved one is the one that is screaming at you when you are using in abstractions in places where you shouldn't. For example, you're having a private iList field and you're not exposing it to anyone. So instead of using an iList, you should be just using list and not having the overhead of virtual method calls. However, people like Egor are working on removing the overhead of virtual method calls and getting them inlined. But overall, you should stick to some good rules and, for example, be also using sets in an efficient way. So we have new analyzers. There is plenty of other things that were moved from R9 to .NET. You can find the full list over here. I'm going to share the slides after the talk. Some important mentions, we have new hashing algorithm. We have a possibility to verify if given base 64 string is valid or not. We have new utility for formatting strings that are not known at compile time, for example, resource strings. And we have a new abstraction for imeter. And this list hasn't been completed, so you can take a look and see what's on the to-do part. The next thing is ASP.NET. The main focus in ASP.NET, at least from my perspective, was on metrics. So metrics, as you know, are measurement over time. In the past, in .NET, we had event counters, but they were quite limited. They were very Windows specific. And now we were adopting to standards set by OpenTelemetry. In .NET 5 or 6, we have introduced system diagnostic metrics, which are much better than event counters because, for example, they can be multidimensional. They are not just single values. You can have also histograms. And to tell the long story short, big part of ASP.NET has been annotated with metrics. So it's reporting metrics everywhere where we believe it matters. Moreover, all these metrics were documented. So yeah. I see that some of you are smiling, but I was at a meeting when people were, saying that, hey, we have added metrics here and there, and I was like, I have one question: do we have docs for that? No. I was like, look, we need to provide docs because otherwise people won't know what these numbers mean. So we have the docs, and we provide some ways of visualizing that. I'm going to talk more about it in the Aspire part, but if you're willing to get such a dashboard, you can click at this link where we provide a link to a repo with a setup for such a thing for every ASP.NET Core app. Another thing added to ASP.NET, there were a few middlewares added. One is iException handler, so basically like a global exception handler. So for example, if you had your app logic copied, where for example everywhere where you were like handling specific exceptions in specific way, you can move them to a new middleware. A good example is DB exception. You can check, is it a development environment, and return all of the information. And if it's not, then just, you know, return generic error information. But we, of course, don't encourage you to use exceptions for controlling the application flow. Another important, from our perspective, is short-circuit middleware. So we have added plenty of logging and telemetry and metrics to ASP.NET. But as you know, websites that are available in the public, they are being constantly read by some bots that are just scrapping the internet. And if you log every single request to your application, then they create noise that you will most likely don't want to deal with. So this API allows you to specify short circuit. So for example, if you just specify paths or prefixes, ASP.NET won't invoke any middleware. It will just return 404 and do nothing. So it's going to help you to reduce the noise. You can also, of course, customize it and log something if you want. There are more things that were added to ASP.NET in .NET Core 8. One that I believe is worth mentioning at least is iResetable interface. So ASP.NET is providing an object pool. Now objects that implement this interface, you can reset them once they are being returned to the pool after you stop using them. A very interesting middleware, request timeout middleware, where you can specify timeouts for your requests. And as I said, a lot of logging, a lot of metrics. And everything that we believe that isn't general purpose enough to be part of .NET or ASP.NET specific, but worth of open sourcing, has been moved to a new repository called .NET Extensions. I'm not sure if it's new, maybe it was internal for a while, but it has been resurrected. So it contains plenty of new packages that were used by these all high-scale services. Two of them are related to testing. You can read a great blog post from one of our architects about it. And to tell the long story short, we have one package for fake time provider, where you can, most likely each of us has implemented such utilities in the past. The same goes for logging, like fake logger, metric collector. Now we are just providing packages so you don't have to copy this code from anywhere. And one of my favorite additions, Microsoft Extensions HTTP Resilience. So during .NET 8, Microsoft has cooperated with Poly, an open source project. We have contributed some performance improvements, some API design ideas. Thanks to that, Poly has released new version, and we have released new packages that are built on top of Poly. This package for HTTP Resilience, it allows you to set rate limiter, which is the maximum number of concurrent requests to a given dependency. You can specify the retry policy. You can specify the timeouts for every retry attempt and all of it all together. And you can also specify circuit breakers. So for example, stop sending requests when there are too many errors returned, or when it's getting slower and slower to get the responses because maybe you are starting to DDoS your dependency. And this blog post is really awesome. It was written by an engineer who works on the team of who owns the backend for Teams. Some examples. Can you see anything, by the way? Yeah. Okay, so if you do something like services.add HTTP client, you're registering HTTP client factory for this name. And if you just use method called add standard resilience handler, you're enabling all of the defaults that all of the people that were building this high-scale services believe that they are the reasonable defaults. So default max retry count, default, timeouts, etc., etc. Of course, you can customize everything if you wish. And another cool feature is that you can specify heading. So what is heading? Heading, to improve the latency, you can perform multiple requests at the same time to multiple dependencies, and whoever responds first, then you take this answer and this is your answer. So you can define groups. For example, here we have 2 groups, and in each group you can specify multiple endpoints. And for every endpoint, you can also specify the probability, the weight that it's going to use. So for example, if we are going to use it like here, where we have just HTTP client.get async or any other method that is performing a request, out of the box, it's going to, run some random, choose which of these endpoints to use, start one request, and at the same time, most likely on the other thread, maybe not, it's going to choose another endpoint from the second group, and it will perform 2 requests at the same time. When I was preparing this presentation for Gdańsk user group in November, I was told that all these packages are going to receive dedicated blog posts soon. It didn't happen, so I will briefly mention a few things about some that I believe that are worth keeping in mind that they exist. So first one is Microsoft Extensions Object Pool Dependency Injection. So this is a package that allows you to integrate object pool with your dependency injection container. So you can resolve objects directly from the pool, and when you and for example, when given context is being disposed, they are being returned to the pool. Another one, Maciej mentioned GDPR today. So we have few compliance packages here. To tell the long story short, they provide some attributes that you can annotate your code. For example, you can specify in the code, for example, in your EF code, that I'm storing a user email here. And they come with a tooling that allows you to generate a report for your compliance team when they come to you and they are like, what kind of private information we are storing in the system? Instead of just scratching your head and be like, I don't know, you can just run this tool and it will generate report for you, because it will read all of these annotations and hopefully make your life easier. So at this moment of time, it was like the middle of .NET 8 release, and we got to the conclusion that, and we started asking ourselves a question like, is it enough to make our customers successful? Is it enough to make it easy to write cloud-native services in .NET? Do you believe that would be enough? I don't see anybody saying yes. So we got to the same conclusion. And the urban legend says that few of our architects sat down in a meeting room for a few weeks and started prototyping, exchanging ideas, building on top of prototypes that we had in the past, like Project TIE, and they came up with an idea of .NET Aspire. So what is Aspire? It's opinionated stack for building cloud-native, distributed, and observable applications. And typically in .NET, we try not to be opinionated, so we provide you a bunch of APIs for achieving whatever you want. In case of Aspire, we were like, this time we need to be opinionated. So how you can use it as of today? On Windows, if you're on Windows, you need to have Visual Studio 2012 17.9, Preview 1 Plus. But don't worry, it's not mandatory to have Visual Studio. You can just install .NET Aspire workload. On Windows, you also need to use WSL and Docker Desktop. By the way, if you don't know how to install something in Visual Studio, there is this search icon at the top. You can just press it and put .NET Aspire, and it will lead you directly to the installer. I have discovered it very recently. For non-Visual Studio scenarios, as I said, we have this new .NET workload, Aspire. So it's not mandatory to have Visual Studio. And in case of Rider, because I know that some of you are using it, I'm also using it. It's not supported yet officially, but they started working on it. And there is a plugin provided by an open source contributor. So you can work with Aspire as of today. But what is important, like, I don't want to scare you with having Visual Studio as a must or a plugin as a must. Most of these things, if you just right-click on a project in Visual Studio, you can see .NET Aspire component and .NET Aspire orchestrator support. So you can achieve all of that without built-in features because all .NET Aspire components are simply NuGet packages. So what it does, it's installing a NuGet package for you. So it's not a big deal if for some reason you cannot use the latest preview of Visual Studio. Yeah, and now let's switch to a demo. Is the font size big enough so you can see it? Okay, maybe I'm going to hide this. Okay, all of my laptops are joined to Windows Insider program, and it means that I'm using always the latest things, and it means that it can break things easily. So because of that, I have, once I got it running yesterday, I just disabled internet. So I'm going to do this talk in offline. This is why I'm not creating a new project, a new solution right now. But if you would like to do it yourself, you can do it. You just need to go to in new project, there is a template for .NET Aspire sample app. So what this app contains? The first and the most important thing is app host. What is app host? This is the orchestrator where you build your distributed application. So you specify all of your projects, all of your executables, all of your containers. You specify dependencies between them. That, for example, over here, I'm creating, oh, it's really small. Over here, I'm creating a Redis container, and I'm giving it ID called cache. Over here, I'm creating a backend service out of a project, and then I'm creating a frontend, and I'm also giving it a name, and I'm saying frontend must be aware of cache and backend, and then I'm building it, and it runs it. And what orchestrator does in development, it starts all of these processes. It spawns Docker containers, it downloads them. I forgot to start Google Chrome before the presentation. Sorry. I'm using a very ancient laptop that is 7 years old, so please excuse me for the performance. It's not that slow on modern machines. I promise. By the way, in Gdańsk in November, I just took my PC because I hated the perf. But this time I was like, no, traveling to Warsaw with a PC that weighs 20 kilograms is not the best. Logs, traces, and metrics. I will talk more about each of them very soon. What is very nice here is that we can debug all of these processes at the same time. So for example, if I get back to Visual Studio and I set a breakpoint in the backend and another one in the front end, And then I got back to the app, and I go to the weather. You'll see that I have hit a breakpoint in the backend service and in the frontend service. So these are two different processes. So the first obvious benefit you get is like being able to easily debug multiple processes at the same time with just a single click. If you take a look at the backend, it's a regular ASP.NET app. The only thing that it does is using add service defaults, and it's also defining components. So what are components? I believe this is my next slide. Yeah, I have already mentioned the app host. Sorry. Before I talk about components, I wanted to talk about named 8 points. So I'm not sure if you have noticed, but in the code, I was not passing any addresses anywhere. I was just giving IDs to each resource. So for example, when I was defining a project, the backend project, I was saying that this is the API service. That's it. And in the front end, when we are registering HTTP client, I was just saying the base address is http://API service. And this feature is called .NET Aspire Service Discovery. So Aspire is taking care of passing all of the necessary information between the processes behind the scenes. And what are components? So every component is just a wrapper around specific client library. And they're all following certain naming conventions. So for example, if we have a component for npg-SQL, we have aspire.npg-SQL. If you have Stack Exchange Redis, we have aspire.Stack Exchange Redis. And the goal of components is very simple. They should enable all of the recommended settings and save you from copy-pasting the same code from every project. So for example, in case of almost all of them, they take care of registering things in the UI, following the best practices. So for example, if you are connecting to Azure and you are using Azure clients from Azure SDK, then it's registering them as singleton. Then the next thing it does by default, it registers health checks for this specific instance. So you won't have two instances running in your app. Moreover, it enables logging and tracing if it's available, and it integrates that. And it also enables resiliency. Typically, we just enable the default timeouts, the default retry counts. But by using Aspire, you know that all of these components, they're just, opinionated, but they are doing the right thing. Like they are allowing you to have an observable application. Last but not least, each of them is coming with app-setting.json schema, which allows you to have completions in app-settings.json. So for example, here I can just go and be like Aspire. We are having the Stack Exchange component for Redis. It's nested. So for example, I can disable health checks. So the idea of components is very simple, and this is the thing that I have been working on. And by the way, it was really a joy to work on such a project, because typically on the .NET team, we work on the .NET itself. It's very hard to build. On a typical laptop, it takes like an hour. There is no way that you can just press Ctrl-Shift-B in Visual Studio and get it running. So what was unique about Aspire to me, I was like, wow, it's building it in 30 seconds. But another unique thing was that, wow, there are no tests. And everybody was like, yeah, but it's early phase of the project. It's hack culture. I was like, guys, we should start writing tests. So for example, to me, it was a pleasure, because I had the opportunity to think of how these things should be shaped and how they should be tested. And I had the pleasure to create, for example, some conformance tests. And I have seen that right now people are contributing new components, and they are kind of forced to follow the best practices because the tests are enforcing that. So we have some cloud agnostic components. We have a component for Postgres using NPG SQL, for Postgres with Entity Framework Core, for RabbitMQ, for Redis, for SQL Server. There are more components coming. There are some cloud-specific components. Of course, as a Microsoft, we have provided Azure-specific components. You have components for blob storage, for Cosmos DB, for Key Vault, for Service Bus, for storage queues. And what was very unique about this project is that in the very early phase of the project, we started cooperation with Amazon. And we told them that, hey, guys, we are working on this idea. Please. And there were multiple calls where we have explained the idea behind Aspire, and they have started working on the components. I don't think that they have been merged yet, but I know that they are work in progress. So we want you to know that it's not an Azure-specific project. And from what I know, Google Cloud is also interested in providing their own components, but I don't have the power to say whether this is certain. And there are more coming. I will very soon show you how many have appeared since November. And each of you can provide your own component because this repository is open source. Maybe what I didn't mention about components is that from the end user perspective, it registers the client, enables the health checks, tracing, logging, etc. But also the orchestrator must be aware of how to pass, for example, connection strings, which containers to use, and this is why the distributed application builder it gives you extension methods like add Postgres container, add Redis container, and behind all of these components they are like pairs. So we provide you a component and something to use to take a container, for example. And now let's take a look at a very nice part of Aspire, the developer dashboard. But I'm going to stop debugging here. And I'm going to run eShop. eShop is our reference implementation of basically an online shop. It's going to take a while to run it on my laptop. But I encourage you to take a look at this repo. I know that many people say that Aspire will most likely work only fine with very simple projects. I will show you how many things this project has. It has like we have Redis container, RabbitMQ container, Postgres, we have multiple databases, we have multiple backend services, multiple web services. They have multiple references. And we specify some environment variables. So as you can see, it can work with non-trivial stuff as well. But let me take a look if it started already. Not. So let's take a look at Docker desktop. So it will start a lot of things, and as I said, my laptop here isn't very new. It's actually a very old laptop. It took me half day yesterday to get it working because it's MacBook, and I wanted to demo Visual Studio. So I wanted to use Windows. So I had to use a utility called Bootcamp, and I also needed to use Docker. But to use Docker, you need virtualization, and by default, it's disabled when you're running Windows on Bootcamp from macOS, but I have found one really hacky way of disabling it. So I was very proud because I really didn't want to just come here with a recording or with a PC. So as you can see, we have multiple web services here, multiple containers. They are all running. One of them is starting. Mobile, I believe, is starting. Oh, and Chrome stopped responding. Maybe it's too much. The web app is starting. But in the meantime, I can show you what dashboard is, because this is the dashboard. So you have access to console logs for each of the processes that you are running. For example, here we can see that RabbitMQ already started throwing exceptions, most likely because my PC wasn't fast enough to start it. We have a lot of exceptions. We have some, oh look, we were inserting some values into database. It's strange. I personally wouldn't insert anything before it's used, but that's fine. We have Postgres logs, Redis logs. Oh, they haven't started. We have also structure logs, and we have metrics. Metrics, these are all of the things that were added in .NET 8. So for example, and they are being updated in real time. So over here you can see that we haven't done anything yet, and we have already loaded over 160 assemblies. We have exceptions, counts, etc., etc. And as I said, we have descriptions of all of this information. So all of this information is super important, so you can have observable applications, so you are not surprised when things are happening in your application. And a very big push in .NET 8 towards, making sure that we can track all of the necessary information. And this trend will continue in .NET 9 because we were not able to annotate everything with metrics. Also, some parts of the OpenTelemetry standards were not finalized yet, and we didn't want to implement something now and then introduce breaking changes in the next release. Let me get back. Has the frontend started running? Yes, it did. Hooray. And now if I go to traces, I would like, you can see the distributed traces for all of the services. And let's log into the app and show you, how much work it's going to take internally, how many requests are going to be performed. It's strange because it has, an exception. How cool is that? But now now we have logs enabled everywhere, so we can at least get this information out of the logs. I have logged in, and if we get back to traces, for example, let's take a look at this one. So here you can see the power of distributed tracing. You can see that we have a web app application that started to do some things. It took almost 9 seconds. The first thing it did HTTP GET to a backend service. This backend performed one SQL query against Postgres, another query, and it got back, and then started performing other operations. We had another SQL query here, another SQL query. Can I see Redis somewhere here? No, I cannot. But this chart gives you a very good overview of what is happening in your app and how much proportionally time it's taking. So personally, as an ex-ASP.NET developer, I would find it very useful. Now let's get back to my demo, to my talks slides, service defaults. So there are some settings that we want to be enabled in every project. For example, we have in case of the sample app, we have backend and frontend, and they are just ASP.NET apps. So we want to enable telemetry for all of them, for both of them. We want to enable health checks. So part of the Aspire template is a project that contains the settings that we believe are our recommendation. They are being just generated as an extra project that is referenced from your source code, and you are free to modify them. So for example, over here, we are also enabling the service discovery, adding the standard resilience handlers, and we also show you how to configure OpenTelemetry. And what is unclear to me now is to what degree we are going to enable the telemetry by default, because it also generates a lot of traffic, and it can be expensive to maintain. So I can see that a sampler has already appeared. So 2 months ago, we didn't have that concept in Aspire. We already have a sampler. So most likely Aspire will come up with some really smart sampler that will be logging things from time to time, or things that are suspicious. Yeah, and deployment. So Aspire itself, it's unaware of how we are going to deploy it. What it does, it generates a manifest file that we accept that other tooling will pick up and allow you to deploy it somewhere. During preview 1, we already had integration with Azure CLI that allows you to deploy Aspire apps to Azure. And in preview 2, we already have received our first community contributions. So for example, there is a community developed tool for deploying Aspire apps to Kubernetes. In preview 2, we have also improved our support for deploying to applications that use Dapper to Azure Container Apps. What else was improved in preview 2? The UI of the dashboard, it was very well received, the dashboard itself. The containers and exits can now reference other resources as well. We have added support for Node.js apps as resources. There are 2 new components, MongoDB and MySQL connector. And it's possible to add a project without a project reference. Currently, you just specify a path. So for example, if you have multiple solutions in the same Git repository, you can just point to a path. The same solution is currently applied to Git submodules, and it's still preview. In preview 3, what has already been promised, and I can talk right now, we are going to receive a Kafka component, and dashboard is going to be separated from app host, and you will be able to use it in production. Here are more sources, and I believe we have still time for some questions. Are there any?
I have one. If someone decides for some reason to run it on-prem, do you see it's like as something doable? Because it looks like it's just Docker running and communication and everything. So I cannot see any issues with this running on-premise.
Yeah, and this is one of our goals, because when we started the project, our main focus was for development, local development. So we have provided all of the features. You can use Redis container, Postgres container, etc. So it absolutely supports non-cloud environments as well. However, of course, if you will be willing to use Azure or Amazon Cloud or anything else, it will take some extra ceremony.
So maybe I missed that one, but everything is kept in the single solution, yes? So,
yes.
Is it possible just to, for example, connect few solutions maybe from different Git repositories just to create wider architecture with much more components? Or it's still...
It's possible, and if I get back here, we have one add project overload that this type is being generated by source generator. So we are referencing here a project from the same solution, but there is another overload for add project, which accepts an ID and a path to a project. But you will need to take care of the relative paths and etc. Yes, please.
If if you get a really large number of components, can you, or is it planned to run just a closure for a given piece? Just, you know, run this piece and everything it needs?
Like auto discovery?
Yeah, I'm not sure if I understand the question.
So if you have a really large system,
yeah,
not everything talks to any other part,
mm-hmm.
and you just want to test one flow, can you run just components required for that flow?
I see. So, for example, you have 20 web services in your solution and you would like to test, let's say, only 2. I think it's absolutely possible, right? But right now, my first idea is to just comment the code that defines other services. I'm sorry, but I don't have a better answers for you right now. Maybe we will have some, you know, command line parsing in the future. I don't know. But for example, over here, you would just need to, you know, comment them out. But also what is very unique about Aspire is that it's in very active development and there is a huge team of people working on it. So it's preview 2 right now. Preview 3 is coming. So the team is very open to the feedback. So for example, Node.js support was added like a few days after the support was requested, after we have open sourced it. So you can post feature requests in the Aspire repository, and as soon as you get non-zero amount of upvotes, meaning that, you know, other people are willing to get the same, and you explain why you are willing to get it, I'm quite sure that there is a high chance that it will be implemented. Because, you know, some people are not happy about the fact that we have shipped something that isn't GA yet, but on the other hand, it's very flexible and we are very open to feedback. So, and we are going to release 1.0 this year. So it's unique because very often we are working on something and then just releasing it and you can use it or not. And we can iteratively improve it over the time, but we cannot make breaking changes. But because this project is still in preview mode, we can make plenty of breaking changes. Matthew?
Yeah, so imagine contributing to a system that contains hundreds of services. What would your assumption be? Do you need to reference every service in that system somehow in the application host, or can you do a dynamic discovery at runtime after you inject it into the cluster?
As far as I know right now, you would have to define everything in explicit way. I'm not sure if there are some plans for automatic service discovery.
So in that case, this assumes that everything is going to be contained within a single solution.
Yes, but it gives you the possibility to reference also executables and containers.
Okay.
Yep.
So a bit more in that subject. So, because I'm looking at this, and what I see is, if I'm going to deploy it, is it like one big deployment of everything I have here? Or, so if I want to, like, for example, have one defined part of the system that I want to deploy separately from the rest, is it like to Aspire and to separate hosts, or is there any kind of other deployment strategies that are being discussed right now?
So the app host, it works only in development, but it's as I said, it's producing a manifest file, and it's up to the tooling how they want to treat it. So I'm quite sure you could define multiple app hosts and specify multiple manifest files and have subsets, but no. And I really encourage you to go to the repo and create an issue with a question and describe why you would like to do it.
What are your plans regarding deploying this? Are you expecting people to right-click and deploy to production, or do you have some specific CI scenarios in mind with some advanced topics like blue-green deployments, canary deployments?
I think right now we are not limiting anything. We just started with deployment to Azure with Azure CLI, but this was the first thing. And as you can see, the deployment to Kubernetes was the second one. And we want to create a standard, so anybody can write their own deployment tool for Aspire.
Do you plan to add functions as a supported project executable?
What do you mean exactly?
I could imagine a scenario where you have some services which end up containerized, but some might end up as simple functions which are front-facing, for instance.
I see. I don't know answer to this question. I would prefer to skip it. And I was taking questions from this side of the audience so far. I apologize. Does anybody from the other side has any questions?
I have one. So when you debug the .NET services, right, does it run them on the Windows or inside Docker?
The projects on Windows, the containers in Docker on Linux.
So the .NET that you showed, the debugger, it runs on the Windows, not inside.
Yes, and also edit and continue is supported out of the box. So you can edit the code.
So do you think it would be okay if you have some set of already created services to just use Aspire kind of on the side just for the local development? Do you think that should work in most cases?
I think yes. If you go with the ceremony of defining the builder and the references between them, and you register the components inside them, which I have shown, it was like for example. To use Redis, it was a single line of code, and to use service discovery. So I can totally see you doing this. You could also introduce something like if defines in the code and have it like, for example, only for debug. Okay, no more questions from this side. Okay, the last row. Sorry.
So the burden of implementing service discovery in, for example, Azure, it's on the people who will write this tool that converts manifest to deployment, yeah?
Yes, and it has been already, in case of Azure, it already has been implemented. You had a question?
Yeah. Do you plan to support high availability scenarios like backup data center in some way in the code, or rather rely on DNS? Or is it for the future?
I think right now it's for the future. Right now it's for the future, and I would prefer to skip this question because, to be honest, I don't know the answer.
Okay, thank you.
Okay, 1 hour is gone. We have only 1 hour left for Shay's talk, so I think I will finish here. Thank you very much.